Okay, last video for this week, last problem. Okay, so I've got a system of equations here where I've got two quadratics. And notice it's y equals in both of them, so if both of these quadratics are equal to y, they have to be equal to each other by substitution. So we just set them equal to each other. So I get 3x squared plus 2x minus 5 equals negative 2x squared minus 4x plus 3. Okay. All right, so it's unlike the last one, I don't have any fractions to get rid of, so we just put it in standard form. So bring the negative 2x squared over, it becomes positive, so I get 5x squared. Okay, bring the negative 4x over, it becomes positive, so I get plus 6x. And then bring this 3 over, becomes negative, so I get a negative 8 equals 0. So let's make sure I got that right. So it'd be 5x squared, 6x. Yep. Okay, so again, I always ask myself, does it factor? Okay, so go to your b squared minus 4ac. Okay, and so I'm going to get b squared is 36 minus 4 times a, which is 5, times c, which is negative 8. Okay, so I'm going to get 36. That will be plus 160. Yeah, 160. Okay, so I'm going to get 196. So the question becomes, is that a perfect square? So we just check it. Second square root, 196. And yes. Okay, this is yes. It's a perfect square, which means that this guy factors. Okay, and we're going to get rational roots. And how about this one? We're not going to have to round anything off. Okay, so let's figure out how we're going to do this. Okay, well, we know the 5x squared gets split up into 5x and x. And I am thinking 4 and 2. And if I put the 2 here and the 4 here, let's see, I need a plus here and a minus here. Yep. So if you look at your O's and I's, we'd get 10x minus 4x. 10x minus 4x is 6x, so we're good. Okay, so we set both of these equal to 0. 5x minus 4 equals 0. So x is going to be 4/5. And then we set our x plus 2 equal to 0. So my x is going to be negative 2. So I know in my solutions, okay, I'm going to get, one of them has an x coordinate of 4/5. And the other guy is going to have an x coordinate of negative 2. Okay, so I got to find the y coordinate. So I got to go back up here, and I want to check myself. Okay, so I'm going to do both of them. Okay, and let's see if we get 3 times 4/5 squared plus 2 times 4/5 minus 5. Okay, and when I do the other guy, I'm going to have to obviously evaluate here, and we'll check that guy out. All right, so let's see. This is 3 times 16/25 plus 2, that would be 8/5 minus 5. Okay, so let's see. If I use my calculator here, all right, 3 times 16/25 plus 8/5 minus 5. Okay, here, and that is going to give me negative 37/25. Negative 37/25. Okay, so let me check the other one and make sure it works out there. So we have negative 2 times 4/5 squared minus 4 times 4/5 plus 3. Okay, so that's going to be negative 2 times 16/25 minus 16/5 plus 3, and then we just go to our calculator. Okay, so let's see. All right, that is going to be what, a negative 32/25, so negative 32/25 minus 16/5 plus 3 and I am going to get negative 37/25, negative 37/25. So obviously it works and gives me the exact same y coordinate, so I should feel pretty good about that, negative 37/25. Okay, so now we do the same thing with negative 2. Okay, so I go 3 times negative 2 squared plus 2 times negative 2 minus 5. So let's see, that'll be 3 times 4, so that's 12, minus 4 minus 5, so that's 12 minus 9, so that's 3. Okay, let's make sure I get the same thing in the other one. Negative 2 times negative 2 squared minus 4 times negative 2 plus 3. So let's see, that'd be negative 2 times 4, so that's a negative 8 plus 8 plus 3, so obviously I'm going to get 3. Okay, so there we go. We got our solutions. That one worked out nice, mainly because it factored. Okay, believe it or not, I did not engineer that problem to make sure it factored. I just made it up on the fly, and we lucked out. So that's it for this week.